All right, let's talk about a molecule that, we all think we know, serotonin. But what if I told you that its real story, well, it's way older, way stranger, and has a whole lot more to do with plant roots than it does with happiness?
So you've definitely heard it, right? Serotonin is the happy chemical. It's such a simple, catchy idea, and it's everywhere. But the actual science? It's way more complex, and honestly, it's a lot more fascinating than just a molecule that makes us feel good.
Okay, so let's just break this down for a second. The popular belief, the happiness molecule, that's super simple. But the scientific evidence, it's kind of all over the place. I mean, how can one single chemical be tied to our mood, but also to things like aggression? And the real kicker, what on earth is it doing regulating plant roots? The whole key here is to stop thinking of it as a mood maker. Instead, think of it as this ancient messenger that helps a living thing figure out how to use its resources.
And to really get our heads around this puzzle, we've got to go right back to the start. I'm talking about one single essential ingredient, one that our bodies actually can't even make by themselves. It all starts with this stuff right here, tryptophan. Yeah, that's the thing you hear about in turkey, but it's also in eggs, cheese, lots of things. Just think of it as the raw material, the absolute starting block. If you don't get a steady supply of tryptophan from what you eat, your body literally cannot make serotonin. Full stop. It is the first and most important link in the entire chain.
Okay, now this is where it starts to get really cool. Life is super efficient, right? It takes this one ingredient and uses it for a bunch of different recipes. I mean, just look at these chemical structures. You've got tryptophan, our serotonin, and then this major plant hormone, auxin. They look so similar. And that's because they all start from that exact same tryptophan blueprint. This family resemblance, that's our first huge clue.
So the process to make it seems pretty straightforward. You eat something with tryptophan, an enzyme called TPH, that's tryptophan hydroxylase for long, goes to work and boom, you get serotonin. But that middle step, the one with the enzyme, that's where the whole system gets incredibly clever. And I mean clever in both our brains and out there in the natural world.
So how do we actually decode what's going on here? Well, believe it or not, some of the absolute best evidence for what serotonin is really for, it comes from a place you would never, ever expect. We're talking about plants.
Right. So in the plant world, serotonin has absolutely nothing to do with moods or feelings. Not at all. Instead, it's this really powerful signaling molecule. It basically tells the plant how to grow and where to put its energy, especially when it comes to the roots. So there's this research on a common little plant called Arabidopsis, and what they found is pretty amazing. If you give the plant just a little bit of serotonin, it starts to grow more of what they call lateral roots, the smaller ones that shoot off the main root. This lets the plant explore way more soil, looking for nutrients and water. It's basically a signal that says, hey, let's expand.
And this chart just shows it so clearly. Look at this. As the dose of serotonin goes up, from 40 up to 160, you can just see the number of those side roots climbing right along with it. The plant is absolutely responding to that signal. It's branching out.
But, and this is a huge but, if that concentration gets too high, the whole effect just flips on its head, completely. Instead of encouraging growth, it slams on the brakes, hard. And here's the data showing that other side of the coin. Once serotonin levels get up into that 300 to 600 range, just look what happens to the main root. Its growth is shut down. The plant literally stops drilling deeper. And that is the key. Serotonin isn't just an on-off switch, it's more like a dial. It's a modulator that fine-tunes the plant's entire growth strategy.
The scientists who did this work, they called it a natural auxin inhibitor. Now, auxin is basically the main go-go-go signal for growth in plants. So by pushing back against that, serotonin is helping the plant balance its budget. It's deciding, should I grow deeper or should I grow wider? It's a resource management tool, plain and simple.
Okay, so it's a growth regulator in plants. That's cool. But how in the world does that connect back to our brains and this whole happy chemical thing? Well, remember that special enzyme we talked about a minute ago? That's the link.
All right, here is the absolute key to the whole thing. The enzyme in our brain that makes serotonin, it's called TPH2, is what's known as a low-affinity enzyme. What that means in plain English is that it's not very grabby when it comes to its raw material, tryptophan. And because of that, the amount of serotonin your brain makes is directly, and I mean directly, tied to how much tryptophan is available in your body at any given moment. It's basically a live readout, a sensor.
So because of that design, anything that messes with your body's tryptophan supply has an immediate knock-on effect on your brain's serotonin production. Think about it. When you're stressed out, hormones start breaking down tryptophan faster. When you get sick, your immune system actually uses an enzyme to get rid of it. And of course, if you're not eating right, you might not be getting enough to begin with. All these different signals from your body, they all feed back to this one molecule.
What this means is your brain isn't just randomly creating a mood, not at all. It's using serotonin levels like a real-time dashboard, checking on the status of your entire body. So if tryptophan is low, and therefore serotonin is low, that's a very real biological signal telling the brain, hey, things are tough down here, whether that's because of stress or sickness or just not enough fuel in the tank.
So when you start putting all these pieces of the puzzle together, from the roots of a plant all the way up to the enzymes in our own brains, a totally new and frankly a much more powerful picture of serotonin starts to take shape.
It doesn't matter if we're talking about a plant root or a human brain, serotonin is doing the exact same fundamental job. It's helping that organism, plant, or person respond to what's happening right now. For the plant, it's about managing physical resources to grow. For us, it's about managing our behavioral resources, kind of shifting our priorities when the body sends up a flare that says, hey, times are tough.
So yeah, it's probably time we retire that happy chemical nickname for good. Serotonin's real job title? It's a master modulator. It's this ancient, highly conserved chemical tool that life has been using for millions of years to change its game plan for survival depending on what resources are around.
So if you're going to take away one thing from all this, let it be this. Serotonin's function isn't set in stone. It's super flexible. It all depends on the context. It creates this direct physical bridge between your environment, like your diet and your stress, and what's going on inside your brain. It's just a stunning example of how life reuses the same ancient tools to solve problems, whether it's a plant in the dirt or, well, you, listening to this right now.
And thinking about it like this, it really changes the whole conversation, doesn't it? The question isn't just, how can I get more happy chemical anymore? It becomes something way deeper, something more like, okay, given my diet, my stress levels, my overall health, what is my body actually trying to tell my brain right now? It's a constant conversation happening inside of you. And serotonin, it's just the messenger.